Lester Martin with Datavolo, and I want to do a demonstration on the Apache Iceberg table format and how Datavolo's visual low-code builder can insert records and files into those tables. Consequence often is about file sizes though, so let's take a moment and think about what we're going to do here. So here is a data file. This is a pretty wide table, and this is just a CSV record. CSV table file here, and about 110,000 records in it, and I think it's about 180 megabytes. Pretty fat, it's big CSV. So what I have set up already is I did set a flow up, so I'm not really focusing on where those files come from, but here's 6 of those files that look a lot like we just said. In fact, it's the exact same records over and over, and there it is. All good, all true. And then the real trick is going to be, let's run our PutIcebergTable against that. So I had to set up a few things, a catalog and Parquet writer, and these records are again coming in as CSV. This is just my namespace and my table name. So let's go and run this thing. Start. I'll refresh it a couple times and make sure those numbers are starting to go down. And there we go. They all have flushed through. So you can see that we have a task out of about 6. And just for giggles, we'll go ahead and run this a little bit more. We'll let our system crunch on a few more numbers and get a few more files queued up in there. We'll let those flow through. I guess I want to make sure I only went about 6. It'll be easy to count. So there's 6 more files, and I'll trigger the rest of this stuff. Now what we'll do is take a moment and say, what's the consequence of all that? Well, it is an Apache Iceberg table called size demo. So let's just go do a quick look, select all from size demo. Use whatever tool makes sense. That's the benefit of Apache Iceberg tables. And here we go. Here's a tool I'm using to see those tables. Like I said, a pretty wide table, all kinds of good stuff. This is the TPC DS, if you're familiar with that benchmark. Now, consequence though is, and I'm going to go back to our canvas here. It looks like everything has worked through. Yeah, 12 files have gone through. Those files were only 110 megabytes apiece. And the way this processor works, it actually takes those and converts those as we configured to Parquet. So if we look in Amazon, so as I click into S3 where my data is stored, there's my bucket, there's my kind of schema, and then the table I was creating is called size demo. Well, we'll see 2 folders. This is how Apache Iceberg works. He puts the actual data files in a data folder. And there are 12 objects here, 12 files here. They're ending with .parquet. These correlate with the CSV files. What should be interesting to note is they're a lot smaller, 4.6 meg instead of, 180 meg. Why? Because Apache Parquet has a much tighter file format. So something to consider. Let's look at that, what that looks like over in our tooling itself, the querying tool. For fun, let's just see how many records we have in there total across, 110,000 with about 12 files. There we go, 1.32 million, not a whole lot. But Iceberg lets us also ask of the current version, what files make that up? So these are those 12 files that are listed. And as you see here, I should have put an as here. These is the record count, 110,000. And the other one is the size of the file, 4.86 meg. So these are really small files. What we were suggesting is we want to build up about 512 megabytes on average. That's to be a good file size of these Parquet, but that means we need a lot of volume coming into us at once. In the Datavolo UI, here is the controller service, the Parquet Iceberg writer that's controlling that 512 meg. Now, the problem here is it's not going to take more than one file that's under a certain size and build it to that. It's just simply saying if the data is bigger than that in the converted in the written Parquet file, we'll stop it, write that 512 one, and work on another one. So what are some strategies if it's the other way around, which is the files are too small? And that's the situation we have here. So we're going to stop our processor, and we're going to show something that we could do. We could inject into the middle of our flow a processor called a merge record. So let me connect them up, and then we'll talk about the settings of something like that. So we'll take the merge records. And what we can do inside of this guy, we can simply say, hey, how do I want to configure this thing? So this, again, still all coming in and going out as CSVs. And if you have a lot of data, we can play with this, but I have a pretty small data set. So I'm simply saying bring in one big file of CSVs and another until I hit some thresholds. And the thresholds I think I set up, or hey, if I hit 50 billion records, put them in one new file, replace that however many before that into one. Same thing, if it gets bigger than 2 gigs, stop there. Or if it takes more than 90 seconds to satisfy either one of those. So I'm going to see what this does when I kick it all off and start running it. So let's go ahead and grab some files to read. From there, we'll go ahead and kick off everything else. And looks like I need to mark the failure as it's okay to keep on moving. And at this point, there we go. We got a few files waiting. We'll start it up, and then we'll pause here just a second and see what happens. We see happening is actually we hit some thresholds, which is good. We slowed ourselves down. We weren't trying to write this. This will give me a good time to stop these other activities, just so we don't read anymore and all that kind of good stuff, and focus on what's already in here. So I'm going to list the queue. These are the outputs of that merge record. These are a little bigger than before, about 378 meg. So that's about 2 of those files that were being put together. Still not gigantic. Lots of things we can do to make that get bigger, but the main point I want to show is we could slow down, collect some information, and then clump it together and then move it down the pipeline. Obviously, the consequence of that, as I kick this off to run, is that we're delaying our input of data into the Iceberg table by a little bit of time. So we're going to have to find that right mix of how fast do we need a query on it, and what consequences do we have long-term of continually sending more and more smaller files into S3, to the S3 bucket that are backing that table. So let's go take a look and see what that looks like on the other side. Let's let these finish draining out first. All 3 of those files have gone through. And if we remember, well, let's just jump over to S3, the bucket. If you remember, we had 12 relatively small files, 4.6 small files. I'm going to refresh this. We have 15 files now because we added 3 more files. And they weren't much bigger, just 5 times bigger. Still too small of a Parquet file for comfort, but we'll be better off with ones that are 5 times bigger, and we'll be better off if those were 10 times bigger, but that's a longer conversation. So the main point was to show that absolutely you have some approaches and mindsets that you can do, and primarily for us, it is that combination. Get in as fast as you can if the records are small, or pause a little bit and bring those records a little bit later. The good side of all that is if we look over at a query engine at that table itself, and we ask some questions, again, we're going to run that same question from earlier. Show me how many files are present, are backing this file. Well, we should have about 15. Yeah, 15 rows. And as you see, most of them, those 3 of those are a little bigger and a bunch are smaller. Well, engines and Apache Iceberg has a concept called compaction. So compaction is going to allow us to look at those files and say, hey, is there any way we can rewrite them to a fewer number of larger files as opposed to a smaller number of small files? So let's let that process run and see what we have afterwards. Has completed, and if you remember, we had about 15 files, a couple of them were 5 meg and so on. We're going to run that check one more time and say, tell me what's there now. The good news after compaction, we're still not, in a great place. This table's very small, but it's showing what the power of compaction is going to do for us, especially at size and scale. It made those 15 files shrink down to about 4 files in this situation. We could probably get away with 1 file, they're so small, but this is what compaction is going to do for us. And I point this out, not that we're trying to tackle that in our Datavolo ETL pipeline. We do want to get the data in there rather quickly. We just going to have to play that fine line of immediately or maybe a short duration of time. And we're going to rely on the fact that the reality is with Apache Iceberg, some table maintenance is still going to occur. How often, how frequent, all that good stuff, all depends, size and scale, access patterns and all that. But we want to make sure you see that Datavolo is a great way to ingest data from a variety of sources and locations and load those into an Apache Iceberg table. All right, thank you for your time.